Hello everybody, it's Miss Wiley, and today I'm going to be talking to you about factoring a specific type of trinomial. Now I'll get into what that specific type of trinomial is in just a moment, but first we're going to take a moment and we're going to do a warm-up exercise to review some of the one of the concepts that we have previously talked about. So if you look at the warm-up, the directions say simplify the polynomials. And so here are two problems that they want you to simplify. And the way that you're going to simplify these is you're going to get rid of the parentheses by multiplying. So remember, we talked about multiplying these using multiple distribution in relation to the acronym FOIL. So that's what you're going to be using on both of these problems. So pause this video, take a moment, and do the warm-up so that you can see if you're doing it correctly, and then I will go over it. Click pause. Okay, so you should have paused the video and tried these out. So let's talk about how you do these again. So remember, you first want to distribute the x to both terms in the second parentheses by doing the first, that's x times x, which is x squared. And then you want to do the outside, that's these, x times 5, so that would be positive 5x. Then you're going to distribute the 1 as well by doing the inside. So 1 times x is 1x. You can also just write that as x. And then you're going to do the last, which is 1 times 5, which is a positive 5. The next thing that you do is you combine your like terms, if there are like terms to combine, and you can see there are two like terms in here to combine. Combining those like terms, you should get x squared plus 6x plus 5. Oops, that didn't come out very nicely. There we go. So this is your final answer. Okay, this is a 6. Let me fix that for you. There you go. And number 2, you should have done the same process. Obviously different answer. So we do m times m, that's m squared. Remember, when you multiply, you add exponents. These each have a 1. 1 plus 1 is 2. Okay. Then you do m times 6. That's the outside. If you're thinking about FOIL, so that's positive 6m. Then you have to distribute the negative 4 to the second parenthesis as well. So negative 4 times m is the inside. So that's negative 4m. And then negative 4 times 6, that is negative 24. And again, you have to take a moment and simplify by combining like terms if there are like terms to combine. In doing that, you should have gotten m squared plus 2m minus 24. Okay. The result of both of these answers is a special type of trinomial. And since the highest exponent is a 2, it's called a quadratic trinomial. So these trinomials that we're going to be factoring today, or that you can see in the title, they're what we call quadratics. So today we're going to be talking about factoring trinomials. Specifically, these trinomials are going to be what we call quadratics. Quadratics are, if you remember, they are special polynomials where the highest exponent is a 2. So that's what you're going to be seeing today in these factoring trinomial problems. So the form that these are going to take is going to be the form of ax squared plus bx plus c. Now what's important to remember here is that this is a trinomial. Remember, it's a trinomial because it is 3 terms. It is a quadratic because the highest exponent is a 2. And we have this a B, and C. The A, B, and C here, these are acting as your coefficients. Remember, coefficients, it's a fancy word for a number in front of a variable or possibly a constant. So these are all coefficients, okay? Where C is the constant, B is the coefficient of the first degree term, or your x, and A is the coefficient of your second degree term, which is the x squared. So that's how we'll always designate those two. So anytime that you have a trinomial in this form, something to know is that for these problems, the way that they are going to factor is it will factor into two binomials. It's going to look similar to the original problems up here in the warm-up. Okay? So let's imagine that you were given, let's say that they ask you to factor a trinomial expression of x squared plus 5x plus 6. This is actually a little bit of an easier example, and I'll explain why that is as we go along. So something in this form is going to factor into two binomials. So what those two binomials are going to look like, and so I'll do this sort of thinking off to the side. This is my thinking. The way that these are going to factor is going to look like something like x plus p times x plus q, right? Where the P and the Q are going to represent some kind of number, positive or negative values, okay? So let's just for a moment talk about what would happen if we multiplied this, okay? So using that FOIL multiple distribution method on it. So if we went ahead and do that, we would be x times x is x squared, x times q is going to be qx, p times x is going to be px, and p times q is going to be pq. Okay, and following along with the process where we would combine like terms, these are x terms, we would be left with x squared plus, now I can't literally add p and q together, but I can represent it as a quantity of p plus q times x. And then that's plus PQ, right? So the coefficient of x is going to come from adding these two numbers together. So what you can see here from this problem, as we're going through this thought process here, I'm going to continue my thought bubble because I'm still thinking, right, that this coefficient of x, this right here, let me get a different here. This coefficient of x here, p plus q, is going to be the coefficient of x, which if you look at our original problem here, our coefficient of x is 5, right? So that means that the p plus q, these values of p and q, they need to add to give me 5. So I need my p plus q to equal 5. Then over here, right here, on the p times q, right? On the p times q, that's going to be represented of a representation of our constant here. So what that means is that the p times q, put a dot there if you want, is going to have to equal 6. So what we need to come up with is two numbers, okay? So we need two, put that here. So I need two numbers where the sum is 6, but the product, sorry, the sum is 5, I messed that up. The sum is 5 and the product is 6. This takes you back to one of the assignments that we did prior to the break, where I gave you a sum and a product, and I asked you to come up with two numbers that did that. So think about the ways that you multiply to 6. Different ways that I multiply to 6 would be 6 times 1, 2 times 3, right? And you can also think the opposite, 1 times 6 or 3 times 2, same thing, right? And think about which of these, if you were to add them together, would give you 5. Well, if I added these two together, they would give you 7. So that's not going to work. If I add these two together, it's going to give me 5. So two numbers whose sum is 5 and product is 6 is a 2 and a 3. So that means that our values of P and Q are going to be positive 2 and positive 3. So you could say that this is your P and this is your Q, or vice versa. Okay? So like I had said before, this is going to factor into the form of x plus some value P times the parenthesis x plus some value Q. Okay? And we had come up with that these two numbers here, they need to add to give me my value of B, and they need to multiply to give me my value of C. Okay? So that means that's going to be 2 and 3. So this is the factored form of x squared plus 5x plus 6. Okay? Now, to show you how this ties into what we had previously learned, let me take that and do a little check. Now, you can check any of your answers by foiling it back together or using multiple distribution. Okay? So in doing this, right, I can see that when I multiply x times x, that's my first, right? That's going to give me my x squared. And I multiply the outside. That's going to give me my 3x. Whoops. When I multiply my outside, x plus 3, that's going to give me my 3x. And then when I go to multiply the inside, that's going to give me my 2x. Now together, this is where the 5x is coming from. It's coming from multiplying the outside and the inside of FOIL, those like terms that you get. And don't forget, you also need to multiply 2 to the 3 to get you your last term. So that's where the product of the last terms comes from, is your value of C. Okay, so you can easily check this by doing some foiling, and you can see here's your x squared. The 5x comes from the outside and the inside of FOIL, or those like terms that you are combining, and the 2 times the 3 gives you your constant value there. Okay, so really what you're looking for is you're looking for two numbers that add to get you your B value and multiply to get you your constant value or your C value. Okay, so we need two numbers that give you a sum of the B value and the product of the C value in the form, if you're thinking about the form of ax squared plus bx plus c. Okay, so let's summarize this a little bit. Okay, so if you have the form of ax squared plus bx plus c when a equals 1, okay, you know that it will factor into two binomials, And those two binomials will take the form of x plus some value p times x plus some value q, where this value of b, where this value of b is represented of the sum of p and q, and this value c is represented by the product of p and q. Okay? Some people like to call this method guess and check, because you make a guess and then you're checking to make sure that it all works out. So you make your guesses, like this is my guess. And I'm sort of checking to make sure that not only do they multiply to the c value, but they also add to the b value. Let's do another example. These problems take a lot of practice, okay? So please be patient and don't say, oh, I already don't get it. We want to persevere here and we want to keep going.